Okay, so the directions will say multiply or divide, simplify, something like that. All right, so here you want to divide these two rational expressions. What's the first step? Change it to a multiplication problem. All right, so the first fraction stays the same. The first rational expression will stay the same. Division becomes multiplication, but then remember, when changing a division problem to multiplication, you got to multiply by the reciprocal. So what does this rational expression become?
3x squared minus 5x minus 2 over 9x squared over 1.
Okay. Yeah. So now, what's the next step? Factor. How do you factor that first numerator?
4 times x plus 2.
So the GCF is 4. What about the denominator?
7x times
So 7x is GCF, so it becomes 7x times what?
x minus 2.
Okay, times. All right, the numerator, that second fraction, second rational expression. GCF is 1, so let's do the two binomials. 3x, x, 2 and 1, there's only one possibility. And the 2 will go in that second parentheses, 1 here. Remember the last sign's negative, that means the signs are different. And for this case, since I want a negative 5x, that means that the 2 would have to be negative. And that 1 would have to be a plus 1. Now always check yourself. If you look at the outer is a negative 6x and the inner is a positive 1x, and I do get that negative 5x. How do you factor the denominator?
3x plus 1, 3x minus 1.
What is that?
Squared.
Difference of two squares.
I know this in class, but I can do it I know, right?
All right. Now, that's where we're at. So then we go through all the factors and look to see if there's anything that we can reduce or divide out. The first factor listed in the numerator is what? 4. Will 4 reduce anything in the denominator?
No.
No. The next factor listed is?
X plus 2.
Will that reduce anything down there?
No.
Nope. The next factor is?
3.
Can I reduce that?
Yes.
Yes. Now remember, when you reduce them, what factor is left in their places?
1.
Ones. Next factor is?
X minus 2.
Can I reduce it?
Yes.
Yes. Okay. And so then you write your answer. Now leave it in factored form. Don't multiply anything out. But you got to write it in one fraction, one rational expression. So you're going to say 4 times x plus 2 times 1 is 4 times x plus 2. 7x times 1 times 3x minus 1 times 1 is? Times 3x minus 1. You're done. That's your answer. Okay, leave it in factored form. All right, so that was basically a quick review. Now, remember in some of the worksheets you are going to have opposites. So let's suppose you had, let's see, I'm making this up, so this may not work out well. Let's suppose you had 3x squared minus 10x plus 8 divided by 7x minus 14 times 21 divided by 12 minus 9x. All right, so you will multiply these two rational expressions. All right. So it's already written as a multiplication problem, so what's the next step? All right, so how do you factor that numerator? First one. Three x and x, there's only one possibility for that. Now 8, I could try 8, 1, 4, 2. Which one do you want to try?
4 and 2, 4 and 2.
4 and 2. The 4 would have to go which parentheses?
First.
I don't think so. The second. Is it the second? No, nope. Not the 4. I'm sorry. Because if you put the second, look, if you put it here, that's going to be a 12, right?
Right.
The last sign's positive means the signs are the same. So you'd have to say 12 plus another number, and you won't get a 10. So the 4 would have to go here, I think. And the 2 has to go here. That'll work. Because the last sign's positive, it means these signs are the same, and they have to both be what? Negative. And you will get a negative 10x. Because the outer's a negative 6x. The inner's a negative 4x. When you add them up, you get negative 10. The denominator?
7 times x minus 7.
Okay. 21 divided by, all right, the denominator here times, okay, all right. All right, now let's start reducing. What's the first factor you see? All right, can I do anything with it? Yes, you can. You don't see it exactly, but what do you see? It's opposite. 3x minus 4 and 4 minus 3x are opposites. So remember what we do, it does not matter when you divide them out like this, it does not matter which one is the factor 1 or which one's a negative 1. But let's make the top factor the negative 1. So this will be negative 1, this will be what?
1.
Positive 1. Because remember when you divide opposites, you get negative 1, right? The next factor is x minus 2. Can I reduce that? Yes. What about 21? Can I reduce it with anything? 7. 7 to 7 is 1. 7 to 21 is 3. What else can I do? These 3's here. Right?
Yes.
And so I get negative 1 times 1 times 1, which is negative 1. The denominator, 1 times 1 times 1 times 1 is, so what's the answer? Negative 1. All right. Okay? All right, now, so as a quick review on this, it's not difficult, it's fairly easy. In order to be able to do these, though, you have to know how to factor. Okay, now, okay, so remember many years ago, like several, what do you call it, light moons or whatever? Light years, thank you. Several light years ago. How would you do something like this? Okay, find a common denominator. So what's the LCD? And we always choose the least. You don't have to choose the least, but it helps if you choose the least common denominator, because there's an infinite number of common denominators. What's the least here? 15. But there's some other common denominators. 30, because 3 and 5 go to 30. There's 45. 3 and 5 go to 45. So there's an infinite number of common denominators, but there's only one least common denominator. There's a common denominator that's the least. So then what you did next was you wrote equivalent fractions with that least common denominator. So you said, I'm going to write 2 fractions with 15 as a denominator. And then you wrote equivalent fractions. 3 times what's 15? So when you multiply the denominator by 5, you also had to multiply the numerator by 5. And so this would be 35. And then over here, 5 times what is 15? And what you do to the denominator, you do to the numerator, so it will be 6. And so then your answer would be, what, 41 over 15? If you want to write this as a mixed number, you could have. That would be 2 and 11, 15. All right. So in this case, in this course, you're not just dealing with numbers anymore, you're going to be dealing with variables. So then you have to learn how to find least common denominator where you have variables. All right, now we're going to, section 14.3 is the easiest section because you're going to notice that for the most part, the denominator is already the same. So let's just start with some examples from 14.3. So this is section 14.3, and basically what you're doing here is you're adding and subtracting rational expressions. So remember the last section you multiplied and divided, right? Now you're adding and subtracting. Now in this case, in this section, the denominators are the same. So these will already have like denominators. All right. So let's look at number 6. And that's on page 1058. You have 8y divided by y minus 2, subtract 16 divided by y minus 2. So you're going to start out where the numbers are the same, so you'll know what you have to do at some point when we get into the next section. So in this case, I'm subtracting 2 rational expressions. Just like over here, I was adding 2 rational expressions here. The denominators are the same. I got the denominators to be the same. Once the denominators are the same, what did I then do? I added them up. I wrote them as one fraction, right? What do you notice about these 2 fractions here? Now, I call them fractions, but they're really called rational expressions. What do you notice about these 2 rational expressions? They have the same denominator. So that means, just like it is here, I can write this as one rational expression. So I can write this as one rational expression. So in other words, now remember when you write this as one rational expression, the denominators stay the same, right? So when I write this as one rational expression, what's going to be this denominator? All right, and all I do is do what the numerator says. So what is the numerator? I'm sorry, what do I do to the numerators? Subtract them. So this will be 8y subtract 16. So that's where I'm at. I'm not done, but that's where I'm at. So when we get to the next section where the denominators are not the same, at some point you're going to make them the same, and then you get to this point. Now this is, remember the directions are going to say simplify if possible. So to simplify this, what do I need to do? Factor the numerator. That brings us back to section 14.1. So now we're at 14.1 now. So what can I do to the numerator? Factor out an 8, so I get 8 times y minus 2 divided by y minus 2, and then what can I do? Reduce. So what's the answer? 8. All right. So you're going to use the previous sections to help you with this as well, plus stuff you've had in the past, courses. All right, so that's number 6. All right, number 4. Number 4, you have 3p divided by 2q plus 11p divided by 2q. All right, so what do you notice about these 2 rational expressions? Yeah, so I want to add them. So when you add and subtract rational expressions, you have to make sure at some point you have the same denominator. When you multiply and divide, that's not the case. The denominators are don't have to be the same. But when you add and subtract, they do. They're the same, so I can write this as one fraction, one rational expression. So what's 3p plus 11p? Divided by, am I done? Nope, because I can reduce 14 and 2. So what's the answer? 7p divided by q. All right. Of course. Yep. 16, you have 4p minus 3 divided by 2p plus 7, and you're adding 3p plus 8 divided by 2p plus 7. Again, notice you're adding two rational expressions. What do you notice about the denominators? They're the same. So can I write it as one rational expression? Yes. I'm adding these two rational expressions. So that's the easy kind. Adding is the easy kind. So my denominator is going to be what, though? 2p plus 7. All I do is add the numerators, combine like terms. 4p plus 3p is 7p. A negative 3 plus a positive 8 is positive 5. So that's where I'm at. Okay, all I did was combine like terms. Yes.
Well, since, never mind. I was about to confuse myself. Never mind.
Okay.
Never mind. I was trying
Now,
to figure it out.
the next step is to reduce. Can I reduce anything? To factor first, can I factor anything? No. 7p plus 5, the GCF is 1, and you can't factor this binomial. Same thing for the denominator. So you're done. That's the answer. Okay? Don't make the mistake of doing this. You can't do that. P is not a factor of this numerator. P is not a factor of this numerator. Your numerator has what factor? 7p plus 5. That's your factor. Now, if this 5 wasn't there and the 7 was there, then could you divide out those p's? Say again? If the plus 5 and the plus 7 was there, if all you had was this, then could you divide them out? Yes. Then you could, because now p is a factor in the numerator. 7 is a factor. 2 is a factor. P is a factor. But the fact that you have 7p plus 5, 7p plus 5 is the factor. Okay, so you got to remember these things, that you cannot do that. All right, now, so adding's the easy kind. All right, we did want subtraction. You see right here, that was not difficult for you, right? Because you were subtracting a monomial. You were subtracting monomial. So let's look at this one. This is number 12. You have 3y divided by y squared plus 3y minus 10. Subtract 6 divided by y squared plus 3y minus 10. All right, so I'm subtracting these two rational expressions. What do you notice about the denominators? So I can write them as one rational expression. What's the denominator? Yep. What's the numerator? 3y minus 6. Now that was easy because I was subtracting a monomial. Am I done? No, you got to factor next. Go back to 14.1, where you've given one rational expression, you have to reduce. You have to simplify, so you have to factor first and then reduce. What can I do to the numerator? So I'm left with 3 times. Okay, what about the denominator? Okay, y plus 5, y minus 2, yep. Okay, now what can I do? Reduce. I get the y minus 2 divide out, so what's the answer? Yep. Okay, so that's number 12. Not difficult. 14. 14. X minus 1 divided by x squared plus 5x minus 6. Subtract 2x minus 7 divided by x squared plus 5x minus 6. All right, so you're subtracting two rational expressions. The denominators are the same. So I can write this as one rational expression with what denominator? Okay. Now, let's talk about the numerator. If I were to write out the numerator, all terms in that numerator here, you'd have 3x minus 1. Tell me what the rest would be. Okay, minus 2x minus 7, right? Okay, this is what someone said. Someone said this.
You gotta combine like terms, correct?
What now?
Would you combine like terms?
Now you would combine like terms, but let's not talk about that just yet. So this is what she told me, okay? All right, so I'm going to ask you this. If that subtract 7 wasn't there, then would this be correct? Okay, so then why did y'all tell me this was not correct then? If that, why did y'all tell me this was correct? 3y minus 6. You told me that was correct.
Because you only had one line.
They were monomials.
Yeah. You
It has to be
Uh,
factored.
can still
No, I'm not. Let's not worry about factoring yet, okay? I'm asking this.
combine like terms.
Okay, let's not worry about combining like terms yet either. Y'all never said anything when I said that my numerator is going to be 3y minus 6. Okay? Y'all didn't say that was incorrect.
It doesn't have a coefficient.
What doesn't have a coefficient?
That's 6.
6 is a constant. When you talk about coefficients, you're talking about a number times a variable, where that number is a coefficient. Why is it then, if I were to cover up this negative 7, you're telling me that when I write as one fraction, 3x minus 1 minus 2x is not correct?
Because you can take 2x from 3x.
I'm not asking about combining yet, guys. I'm just asking you, is it correct to say what these two numerators I can write as 3x minus 1 minus 2x for right now?
No, you can't have too many minuses.
You can't have too many minuses.
I don't know.
What are you talking about? Can't have too many minuses.
You know how mentally you're combining like terms already?
Don't do that.
Writing it out.
I'm asking you just to write it out.
Yeah,
I'm not.
write it out.
Okay, all right, thank you.
Oh.
All right, now, suppose the 2x wasn't there. It would be a positive 7. That's where I'm getting, that's why I'm bringing it up, because you said it was 3x minus 1 minus 2x minus 7. That's incorrect. It's minus 2x plus 7. So the others were easy. I thought it was. Because remember I kept saying this is a monomial. That's the easy kind. You're subtracting a monomial. Here you're not subtracting a monomial, you're subtracting a binomial. So you got to subtract every term that's in the numerator. So subtract 2x, and when I subtract a negative 7, it really becomes what? Plus 7. That's what it should be. So to be on the safe side, see how some of you messed up, to be on the safe side, you may want to do this first. And it's up to you, but the numerator really becomes 3x minus 1, and you're subtracting in parentheses, you're subtracting 2x minus 7. That's what you really have there. And then to get rid of the parentheses, you're going to distribute a what?
Negative.
Negative 1. So then it becomes 3x minus 1 minus 2x, and then what? Plus 7. So you got to be careful when you're subtracting something other than a monomial. So all the signs change. So when you subtract these terms, the sign changes. Positive 2x becomes a minus 2x. A negative 7 becomes a positive 7. And it all goes back to you're subtracting this numerator, so you distribute that negative 1 through there. Now what's the next step?
Combine.
Combine like terms. What's the numerator?
X plus 6.
Okay, and the denominator is x squared plus 5x minus 6, right? All right, am I done? No, because you got to factor. Because you want to see if you can reduce anything. Direction says simplify. Subtract and simplify if possible. So you have to factor and then reduce if you can. Well, the numerator I can't factor, but I can factor the denominator. All right, so it'll be x, 6 and 1 is going to work, not 3 and 2. And then the 6 has to be what? And the 1 has to be negative. And now what can I do? Divide out this x plus 6's. And so what's the answer over x minus 1? All right, so you now know you got to be careful when you subtract something other than monomial. All right, number 18. 18, you have 6x squared divided by 2x minus 5. Subtract 25 plus 2x squared divided by 2x minus 5. All right, I'm subtracting two rational expressions. When I add or subtract rational expressions, before I can combine them as one, I got to have the same denominator. Do I have the same denominator? Yes. So now that means I can write this as one rational expression. So just list the terms. What's going to be the terms in the numerator? 6x squared, and then tell me what the rest will be. Minus 25 minus 2x squared. Good. That's what that is. So remember what you're doing in your mind, you're saying 6x squared, subtract in parentheses this numerator. And then get rid of the parentheses by distributing the negative 1. So that's where you get that minus 25 minus 2x squared. Divided by 2x minus 5. Now combine like terms. What's the numerator? Minus 25. Okay. Divided by 2x minus 5. Am I done? Nope. What can I do? How do you factor the numerator?
2x plus 5, 2x minus 5.
Difference of two squares, right? Divided by 2x minus 5. And then notice the 2x minus 5's divide out. So what's the answer?
2x plus 5 over 1.
Or, but I prefer you write it as just 2x plus 5. Okay? All right. So, the whole idea between when adding and subtracting, though, especially in the next section, is that your denominators have to be the same. Once they're the same, it's an easy process. So now we get into the point where, well, what if they're not the same? How do you find the LCD? Okay? So let's talk about that. So this is going to be number 22, same section, number 22. So now what's going to happen is this. So you're given two rational expressions, 17x, 4y to the 5th, comma, 2 divided by 8y. All right? All right, now remember, 4y to the 5th. Okay. So you're finding you want to find the least common denominator. The least common denominator. So if you look at the coefficients, now the numerator, you don't look at the numerators, just look at the denominators. This is a 4, this is an 8. What's the smallest number that 4 and 8 go into? 8. So far I know that my least common denominator is 8, has an 8 in it. Okay? Then the other factor I see is a y. Have y to the 5th, have 5 y's here and only 1 y here. Okay? So you got to think about this. What's the smallest factor that y to the 5th and y go into? y to the fifth. Not y. Not y, because y to the fifth doesn't go into y, but y goes into what? Y to the fifth. Okay, so it's kind of like saying this. I want you to think about this. Remember when we had 4 and 8 and 8? Do y'all agree that, and we said that a GCF, I'm sorry, the LCD was 8? Okay, so I want you to think about this. 4 I can write as 2 squared, right? And 8 I can write as 2 cubed. So my base is the same, but did I use the smaller exponent or did I use a larger exponent? I used the largest because that's how I got 8. So my factor is 2. I have how many factors of 2 here? 2. How many factors of 2 here do I have? 3. So I need how many factors of 2 in my LCD? 3. And that's how I get the 8. So now use that idea with the variables. How many factors of y do I have here? 5. How many factors of y do I have here? How many do I need in my LCD? 5. That's my smallest that I need, the least one that I'll need. Okay, so what's the LCD? 8 y to the fifth. All right, so hopefully when we wrote the 4 and the 8 as 2 squared, 2 cubed, you now understand that you got to use the one with the larger exponent. And that's all they want you to do. So in the directions here, we'll say find the least common denominator. So that's going to help you in the next section, because the next section is where you're going to start adding, subtracting with unlike denominators. Okay? Now, so I was 22. Okay, let's look at 24. 1 over 6y, comma, 3x divided by 4y plus 12. All right, to find the least common denominator, you first of all have to factor your denominators. So as we go through the rest of this, we're going to talk about factoring. Now you may say, well, I didn't mention the word factoring in number 22. Well, it's because number 22, those denominators were monomials. So I didn't talk about that. But in 24, not all the denominators are monomials. Which one is not a monomial? The second one. But I know that I can still factor the second denominator. How do I factor the second denominator? Factor out of 4, so it'll be 4 times what? Y plus 3. So as we go through the next section, when we start adding, subtracting with unlike denominators, you first of all have to factor your denominators. Now, how many denominators do I have? Denominators. 2. What's the factor in that first denominator? Give me the first factor in that first denominator. 6. Give me the second factor. Y. Give me the factor here. 4. Give me the factor here. Okay. All right. So let's talk about finding the least common denominator. This is a 6. This is a 4. Always start with your coefficients first. What's the smallest number that 6 and 4 go into? 12. Okay. So far my LCD is going to be 12. Always do the coefficients first. The next one was y, right? So how many factors of y do I have here in this denominator? 1. How many factors of y do I have in that second denominator?
No.
None. I don't have any. Y plus 3 is a factor. When I said list of factors, you said 6, then you said what? Y, then you said what? 4, then you said what? Y plus 3. You didn't say y, you said what? Y plus 3. So I'm going to ask you again. How many factors of y do you have in this one? How many factors of y do you have in this one? 0. Remember, you always use the one with the largest, right? So how many do you need? 1. So far my LCD is 12 what? Y. Okay? Let's go to the next denominator. I already took care of the 4. What's my next factor? Y plus 3. How many factors of y plus 3 do I have here? 1, because y plus 2 is the first, right? How many y plus 2's do you have here? None. How many do I need? 1. So there's your LCD. So your LCD be 12y times y plus 3. 12y times y plus 3. Okay? So every factor you see has to be listed here. So I saw 4. Is a 4 listed here? Yes, because 4 goes to 8. I saw y to the 5th. Is y to the 5th listed here? Yep. I saw an 8. Is 8 listed here? Yes. I saw a y. Is y in here? Yes. Okay. A 6. I saw a 6. Is 6 in here? Yes, part of the 12. I saw a y. Is y in here? Yep, there it is. It's right here. I saw a 4. Is 4 in here? Yep, it's part of the 12. I saw y plus 3. Is y plus 3 in here? So every factor has to be in your LCD. Just like when you did this one. 3 and 5. Is 3 in this LCD? When you said the LCD was 15. Yes. 3 goes in 15. Is 5 in here? Yep. Because you can write it 3 times 5. 5 is in here. Okay? So every factor, once you factor, every factor has to be part of your LCD. Right. So don't make it difficult. It's not that difficult. 26. All right, so negative 6 divided by x minus 1, comma, 4 divided by x plus 5. Can I factor the denominator? Before you find your LCD, you got to factor your denominators. Can I factor any denominator down there? No. So now the next thing you do is you ask yourself, okay, now let me determine what the factors are. In that first rational expression, what is the factor in the denominator? X minus 1. I got to use it, right? All right. The next denominator. What are the factors that you see? I got to use it. There's your LCD. So your LCD is this binomial, the product of those two binomials, x minus 1 times x plus 5. There's your LCD. Okay? $30. So 9x squared divided by 7x minus 14, comma, 6x divided by x minus 2 squared. All right. All right, so if you were adding or subtracting those two, what would you have to do first? Well, even before you found the LCD, you got to factor. Can I factor the denominators? Oh, you'd be hesitating with that one. You shouldn't. What's 7x minus 14? 7 times x minus 2. Okay? The second denominator is already factored because I can write it as x minus 2 times x minus 2, right? There's nothing I can do there. All right, now let's talk about the factors. What are the factors in that first denominator? 7 and x minus 2. What are the factors in the second denominator? X minus 2. How many do I have? 2. All right, so let's talk about the LCD. 7. And that's a 1 here, right? So in terms of 7 and 1, what's the LCD of that? 7. Now let's do x minus 2. I have an x minus 2 occurring here. How many do I have? Do I have them over here as well? Yes. How many do I have? How many do I need? 2. So there's your LCD. And always check. Let's go through each factor again. We said the factor was 7. Do I see a 7 here? Yep. Factor here is x minus 2. Do I see an x minus 2 here? Yep. Next one is x minus 2 squared. Do I see an x minus 2 squared? Yep. You're done. So there's the LCD. 32. You have 19x plus 5 divided by 4x minus 12, comma, 3 divided by 2x squared minus 12x plus 18. All right, so what do you do? Okay, so the first denominator, how can you factor that? What about the second denominator? Now, one person said GCF is 2. GCF is 2, guys. So 2 times x squared minus 6x plus 9, right? And now it makes it a lot easier to factor that trinomial. So how do you factor that trinomial? X minus 3, x minus 3. All right, so that's where I'm at. So I factored completely. Now let's talk about what the factors are. What are the factors in that first denominator? What's the first one? 4. What's the other one? Let's go to the second denominator. What's the first factor?
2.
And your other factor is x minus 3, how many? 2. No, there's no x plus 3.
I'm sorry. I wrote it wrong.
All right, so the LCD. The smallest number that 4 and 2 go into is 4. X minus 3 squared, and that's it. So 4 goes into 4, x minus 3 goes into x minus 3 squared, 2 goes into 4, and x minus 3 squared goes into x minus 3 squared. Okay? Okay, 40. You have 5 divided by x squared minus 25, and then x plus 9.
X squared minus 25?
Yep. And then x plus 9 divided by 3x cubed minus 15x squared. So 5 divided by x squared minus 25. And then the other rational expression is x plus 9 divided by 3x cubed minus 15x squared. All right, so if you were to add or subtract, you would have to make sure your denominators are the same. So you have to find the LCD, but even before you do that, you have to factor. So how do I factor that denominator?
X plus 5, x minus 5.
Okay, difference of 2 squares. What about this one? Factor out 3x squared, you get x minus 5. All right. Now, seeing all this, what do you think the LCD is?
It's going to be 3x squared x minus 5.
X minus squared.
Yeah.
X plus 5.
Wait, say it again?
X minus 5.
He's just throwing it all
It's
out.
3x squared, parentheses x minus 5 to the second power, then x plus 5.
No.
No, what? First of all,
Parentheses x minus 5, parentheses x plus 5.
yeah. Why'd you say x minus 5 to the second power?
Because you got 2 of them. X minus
Where?
5.
Oh, you mean
Yeah,
2 of them
x
here?
minus 5, yeah. Like
Okay, you haven't been listening very well. Okay, listen carefully. Okay, let's go back here. How many x minus 2's do you have here?
1,
1. How many x minus 2's do you have here?
3.
No, you don't. You have 2. Use the one with the largest exponent. Okay. Over here, you have, how many x minus 5's do you have here? 1. How many x minus 5 do you have here? 1. How many are you going to use? 1.
Never mind.
Okay.
I wrote it wrong on my third, that's why I got confused.
Okay. So it's 3x squared times x plus 5 times x minus 5. That's the least. Now, if you put x minus 5 squared, that's not the least. That's a common denominator. Remember we talked about earlier, there's an infinite number of common denominators? That's a common. But you got to use the least. They're going to ask you to use the least. Okay? All right, so you got to know how to find the least. So just because you see 2x minus 5 here doesn't mean there's going to be x minus 5 squared. That's a common one. It's not the least. You have 1 here, so you need 1. Okay? All right. Now, 42 is going to look like this. Now, let me explain. It's very similar to what we just did, but so we have 42, we have 3 divided by 9y to the 5th. All right, now what they want you to do, and this is going to play into the next section as well, and they want you to rewrite this denominator, 9y to the 5th, using this denominator. And so you're going to see how that's going to be used in the next section. So in other words, they want you to write an equivalent fraction. So you're writing an equivalent fraction. So here you see the equal sign, so equivalent, equal. So you want to write an equivalent fraction that has this denominator. And whatever you get here, if you were to reduce it, you would get this back. That's the idea. Well, it's very similar to what we did at the beginning, guys. So when we talked about this right here, we use the word equivalent fractions. I'm going from 7/3 to an equivalent fraction with 15 as a denominator, right? And so to get to that point, we said, all right, I have a 3. What do I want? A 15. So what do I need to multiply the 3 by? 5. What I do to the denominator, I do to the numerator. So that's how I got 35. Same idea here. I want to get a 72y to the 9th. So what is it that I got to multiply the 9 by to get 72? 8. And what is I got to multiply y to the 5th by to get y to the 9th? Y to the 4th. Because remember, you multiply like bases, you add exponents. But what I do to the denominator, I do to the numerator. So I got to multiply the 3 by what? 8y to the 4th. Okay? And so therefore, what's the numerator? What's 8y to the 4th times 3? Yeah. And that's all you do. That's all they're asking you to do here. So basically, you're just writing equivalent fractions. It's not hard. Just relate to what you've done before. So when you look at number 44, let's look at 44. You have y divided by, 5. 5 divided by 4y squared x equal. All right, so you want to find an equivalent fraction that has this denominator. 32 y cubed x squared. Okay? All right, so you want to find out what numerator will be in that second fraction. Well, just like you did with just numbers in the past, 4 times what is 32? 8. So I got to multiply this by 8. Y squared times what is y cubed? Y. And then x times what is x squared? X. So you all agree that in order for me to write equivalent fractions, I got to multiply both the denominator and the numerator by what? 8xy or 8yx, right? So therefore, what's the new numerator? 40xy. So there's your answer, 40xy. Okay? So again, all that's going to be needed when we talk about unlike denominators. 50? You have 5x divided by x cubed plus 2x squared minus 3x. Okay, equal. And you want this denominator. X times x minus 1 times x minus 5 times x plus 3. Now, when you actually do the next section, you're going to notice that when you find the LCD, it's not going to be that many factors. It'll be doable. Okay, so that's what you have. And remember, notice when we talked about adding, subtracting fractions, you had to make sure that your denominators are factored, right? And when we found the LCD, we looked at factors. So these are your factors. Over here, those are your factors. What do you use about this denominator, though? It's not factored. So you got to factor it. Now you may say, well, I didn't mention anything about that earlier. That's because, in these previous two, that's because these denominators are monomials. See that? Those are monomials. Now we have a problem where it's not a monomial. So I need a factor. What can I do first, though? Factor out an x. You get x times x squared plus 2x minus 3. And then you factor the trinomial. What do I get?
X plus 3x minus 1?
Yep. All right, so that's where I'm at. Okay? All right. So this is what I have. This is what I want. Look at what you have, and that's going to be important if you talk about the next section. Look what you have and look what you want. What's missing? Now agree it's x minus 5. So I got to multiply this, that's multiplication, by x minus 5. What I do to the denominator, I do to the numerator. Right here. So your answer, remember you can leave it in factored form, is this. There's your answer. 5x times x minus 5. Okay? Now, sometimes they'll go ahead and distribute this. They'll write this as the now don't multiply this out because you'll be here for a long time in the denominator. But here you could have distributed. So you could have said r 5x squared minus 25x over that denominator. But you could have left it like that. In fact, I'd prefer you leave it like this anyway. Okay, just leave it like that. Okay? Any questions? Let's do one more with this. So that was number 50. Let's look at 52. 52. Okay, you have 6m minus 5 divided by 3x squared minus 9 equal, and you want this denominator, 12x squared minus 36. All right. So what do you have to do first? Oh, I see. So, all right. Yeah, she noticed right away that you could have multiplied by 4, but technically it would have been, you really should have done what? Factor first. But she multiplied by 4 because notice she knows 4 times 3x squared is what? 12x squared. 4 times a negative 9 is what? Negative 36. Yeah. So basically, you really, when we factor and then see what the LCD is, you're going to see that Really, you just multiply by 4.
So if we know that offhand, do we have to do everything else?
No.
Or we just write the answer?
No, you can just say 4 times this. But let's go ahead and factor. How do you factor this? No,
Difference is 2 squared.
no, you got to take out the 3 first.
Oh, 3 out, sorry.
X squared, not X minus
X squared minus 3, right?
yeah.
Okay, that's all you can do. And then you can't. And then technically, in terms of integers, in terms of whole numbers, this is not a difference of 2 squares. Now, in terms of irrational numbers, this is, because you can write this as x minus square root of 3 times x plus square root of 3. You're going to see that in another chapter. But you can't do anything else to this because 3 is not a perfect square. Here, though, what can you take out? It'll be x squared minus 3, right? Okay, so notice where the 4 comes in. I have 3 times x squared minus 3, and I have this. I have the x squared minus 3. I just need to get the what? The 12. So I need to multiply 3 by to get 12? 4. So that's where that 4 comes from. Times 4. So when you write your answer, your numerator, you'd say 4 times what? 6n minus 5 like this. Okay? All right? All right, now, in the next section, though, you're going to see why. But for right now, in the next section, for right now, though, I need for you to, because you're going to see why you have to distribute. So you're going to have to distribute this in the next section. You're going to see why when we get to it. If you distribute, though, what do you get? Minus 20. Okay? And you're going to see when we get to the discussion why you want to distribute. But for right now, you can leave it like this or you can write it like this. But in the next section, you're going to see that you really are going to have to distribute that 4. All right, so any questions at this point? Okay. All right, so now we're ready to talk about adding, subtracting, unlike denominators. Before we do that, let me just show you what your worksheets are. So this is 14.3 Part A. So notice it's just like we did before. What is it about the denominators? They're the same. There is no back. Doesn't say anything about showing work. Okay? Now, don't forget about the subtraction right here, though. You got to be careful. Now, if you don't show the work, though, if your answer is incorrect, there's not any credit I can give you, right? But if you show something, I could probably give you some points. All right. Part B is where you have to find the LCD. Notice it says LCD. It didn't say a common denominator. It says what? The least common denominator. There's an infinite number of common denominators, but there's how many least common denominators? 1. So this one's easy. That's just numbers. Now you have your variables, monomials. Now you're dealing with others, something other than monomials. Okay? There's no back. Then we just finished this one. That's where you define the numerator. So whatever the numerator is, you put the answer here. Okay? And then this is what we did a while ago. So you see the numbers are the same? You write as one fraction, and then you got to factor the number because you can reduce. You'll be able to reduce some of these. So you realize, if you go back to the notes, when we did these, we factored at the end, right? And we saw that the factors can reduce. Okay. So don't just say the answer is 3k minus 1 over this. What else do you have to do? Factor. Notice so it says show all work. Make sure you show the work. And then here's the back part. So there's a back part in this one. Okay? All right, so those are the 3 for that section. All right, so that's a lot of, okay, I see. All right. So this is part A.